Hello and welcome to my video, lesson 3.5, conditional probability. So conditional probability means that it matters what happens for event A because that affects event B. So dependent probability is when event B is dependent on the results of event A, like I just said. Now, the intersection of A and B, this is the formula. This is a formula from the formula from this topic. Although you can do a lot of things without the formula, this is helpful to know. Anyways, the intersection of A and B is equal to the probability of A. So probability of the intersection, I suppose, is equal to the probability of A, all of A, times by the probability of B happening if A has already happened. All right. So basically, it's just saying if they're dependent, then you can kind of find the intersection using this this method here. So there are 11 green, 6 red, 8 blue, 5 yellow gumballs in a machine. Assuming they come up randomly, your friend takes one and you take the next one. What is the probability that you have a red ball? So this is interesting because it depends on what your friend has taken. So you could really do a tree diagram, or you can do a probability multiplication thing to get this. So because I prefer tree diagrams, I'm going to actually do it for both of these questions. Just noticing that this says tree diagram, this one doesn't. I'm going to just do it for both. So first of all, your friend could choose a red one, right? If he chooses a red one, now you have a different probability of choosing red. Or he could choose not red, right? After that, your friend could, you can choose red, or you could choose not red. After this point, you could choose red, or you could choose not red. So there's a few possibilities here. So what is the probability that you choose, or that your friend chooses red? Well, at first it's 6 out of, how many are there? 11 plus 8 is 19, 25, 30. 6 out of 30. Ooh, that's a nice round number. Didn't do that on purpose. And then this would be, I guess, 24 out of 30 for not red. Okay, noticing that every column of these probabilities has to add up to 1, or to 1 over 1. Okay, once he has chosen a red one, now it is a 5 out of 29 chance that you choose a red one, and a 25 out of 29 chance that you don't choose a red one. If, on the other hand, he chooses not a red one, and then you want to pick a red one, you get 6 out of 29 are red, and 23 out of 29 are not red. Actually, I think I made a mistake here. This should be 24 out of 29. There you go. Yeah. So to find out the actual probability for any given one of these situations is to multiply event A times B. So event A is the first one in red. Event B is either in blue or in green, depending on the situation here. So let's try this out. Maybe I'll zoom in a little bit. It'll be a little bit easier to read. Okay, so event A is 30 times event B is 5. Oh, I should probably use the calculator for this, eh? It's probably a little bit better than just talking it through. Okay, so Fraction, no, we don't even need a fraction. We can just go 5 times 6 divided by 30 divided by 29. Okay, so that's the probability in this first one. So 0.034482758 Okay, you can probably just ignore the rest of that and just go to there. 4 numbers is probably plenty. Let's go to the next one, which is very similar, except that it's, instead of 5, it's 29. No, 24. Whoops. So that's 0.1655172. So basically, this is the probability of picking a red, your friend getting a red and you not getting a red is like 16%, 17%. Okay, of your friend getting red and you getting red is like 3%, right? You can see how that would be. So now let's try the next one. 24 times 6 divided by 30 divided by 29. And this gets 0.1655 as well. Okay, and the next one over here, 24 times 23 divided by 29 divided by 30. Okay, anyways, all of those numbers should add up to 1 if you add them up. So that one plus that one plus itself again plus 0.03448. Yeah, and it adds up to 1. Yeah, so all of these numbers should add up to 1. Right? So what is the probability of having a red gumball for you, not for the other person? So that would be these two. If we add these two together, then that would be our gumball probability. So 0.03448 plus 0.165517, and it gets us to 0.199 repeating, so it's probably 0.2, so 20%. Okay, let's take a look at the next one here. So you're playing poker, and you can see the flop, which is the 3 cards after everybody has anteed up, as well as another 2 cards in your hand. If one of your 2 cards in your hand is a heart, and all 3 of the flop are hearts, you draw 2 more cards. Okay, sorry. If one of the cards in your hand is a heart, and all 3 of them are hearts, if you draw 2 more cards, what is the probability of a heart as a second card to give you a flush? Okay, so you draw 2 cards. We don't care about the first one. What's the probability of getting the second one? A heart. Okay, so again, tree diagram in very much the exact same way. I think we're going to need more space though. So we're going to start off here. We're going to say heart, not heart. All right, so this is out of 52. This is out of 52 cards in total. Now, there aren't 52 cards in total, so we actually need to change that because 5 cards are shown. You know what 5 of them are, so let's get rid of 5. So it'll be out of 47. There you go. 47. And how many total hearts are left out of 47? Well, you can see 1, 2, 3, 4 of them already out of the 13 hearts that are in the deck. So there are 9 hearts left out of the 47 cards. Okay, so that also means that we have 38 non-hearts left. Okay, so what that would look like is, or what we should do now is find the hearts. So the probability of getting hearts for the second time. Now we've dropped another card. So we're at 46 cards. And so those are the 2 probabilities. Now we don't care about the other part here. We don't care about these 2 numbers. So we're just going to leave them, and we're going to calculate out, if we multiplied those, what would we get? So 9 times 8 divided by, whoops, I have 8 divided by 47 divided by 46, and we get 0.0333. Okay, so pretty low chance. Let's try the other one. 38 times 9 divided by 47 divided by 46. 0.158. blah, blah, blah. Okay, so we should add those 2 numbers together, and we get 0.1949. Leave it there. So that is the same thing as writing 19%. Okay, now there is just one interesting thing to say. We don't really, in poker, we don't care if it's the next card or the card after. So let's add both of these percentages up. Okay, so let's add both of those percentages. So 9 divided by 47 plus, sorry, not this one, 0.15818664. So if we added those 2 up, it would be 34.968%. So 35% basically. Okay, so tree diagrams are pretty interesting for games. Not that any of us can, well, probably none of us can do this sort of math in your head, but probability is super important for games. So one last question to look at here. Sarah asked Jerry to pick a number between 1 and 30, then to give a hint. Jerry says his number is a multiple of 3. Determine the probability that it is also a multiple of 4. So what are we going to do here? So there's two things it tells us. First of all, use a Venn diagram. So let's try that. Let's try that right now. Okay, so here's our Venn diagram. And let's think about it. All the numbers between 1 and 30, let's not do all of them. But it does tell us to do all the multiples of 3. So 3, 6, 9, 12, 15. Yes, I'm going to take a look at this in a second. 18, 21, 24, 27, and 30. Okay, so all of those numbers. Okay, now it says determine the probability that's also a multiple of 4. So let's take a look at the multiples of 4. 4, 8, 12, 16, 20, 24, 28. So where does it overlap? Well, we have an overlap of the 12. so I can cross those out. We have an overlap of the 24, so we can cross those out. Is there anything else? No. Okay, so you can see here that we have an overlap of 2, or an intersection of 2 points. So determine the probability that's also a multiple of 4. Well, once you know that it's a multiple of 3, there are 10 in total. So maybe I'll just scroll down so you can see that. So there's 10 numbers in total that fit in the 3 category. Right? So out of the 10, 2 of them overlap with the 4 category. Okay, so 2 out of 10. Okay, what else can we do? Well, part B suggests that we could use a formula. So the formula is as given at the beginning here. Maybe I'll just even copy that down. Okay, so that formula is helpful because it allows us to do this without picking each one. So the intersection of A and B. Well, how can we figure out the intersection of A and B? There's a few different ways, but we can figure out that there are 2 out of the 30 are the intersection. So how can we figure out, that there's 2? Well, you can go 3 times 4 is 12, and then just see what multiples of 12 fit into 30. So there's 2 of those. You can also look for if there are any prime factors, but 3 is just 3, 4 is 2 and 2. So none of it relates, so that's why you just have to multiply them. So anyways, 2 out of 30 are in the intersection. That's the 12 and the 24. The probability of A happening is 1/3, because every third number is in that set, right? So you can go all the way, but you can see how every third number is in because it's just multiples of 3. And so we're looking for the probability when A has already occurred. So let's solve for that. Basically, we're going to move the 1/3 over, which is going to be like saying 2 times 3 over 30, which is going to simplify down to 2 over 10, which is this probability of B if A has already occurred. So you can see how this might be helpful as well. All right. I hope this video helps you better understand conditional probability. Good luck.